So good morning, everyone. Thank you for joining today here. My name is Vinodhkumar. I'm a clinical data scientist in the Novo Nordisk. So today I'm going to discuss the exploration of R-Shiny in the quality inspection of clinical programming deliverables. And before that, I would like to acknowledge my colleague and my co-author, Sai Gayatri, who is significantly contributed to this work. And before we're moving on to the presentation, there's a disclaimer that the views and the information presented here solely are those of the presenter and do not necessarily reflect the Novo Nordisk. And no proprietary or confidential data belonging to the Novo Nordisk is included in this presentation. And basically, this presentation contains the two parts. The part one contains the problem statement and the solution. The second part, we will take you through the app we created to address this quality inspection challenges. So in today's highly regulated environment, ensuring the quality not only in the data, but in the clinical programming deliverable is also a complex than ever. It's a critical than ever also. So here, all the regulatory agencies and quality inspections demands accurate, consistent, and precise clinical programming deliverables. So what is the quality deliverable? So it contains a clean logs, a comparison of a clear parallel programming files, and comparison of TFLs or the data sets in a bulk manner, so that we need to get a quick summary to ensure everything is as expected. And we need to find out quickly where the changes had been happened. This is not an exhaustive list that we perform, but we perform many more quality checks when we make a clinical deliverable. But to perform these quality checks, our current practices are we do perform manual checks. And if we are working on the Unix platform, we use Unix commands to perform these checks. And sometimes we use a piece of SAS or R codes to find out the quality of these deliverables. It is time consuming and prone to errors. So we need a robust user-friendly tool to automate and centralize all these checks. To create such apps, we have a package called Shiny in the R, which has some advantages. One is interactivity. That is when the input change, automatically output will get changed. That means whenever our deliverable is refreshed, then automatically the quality report would be generated. That is an immediate feedback feature. And we have a visualization capacity. It is a good feature in the Shiny. So when the reports are generated, obviously we need to look at a summary. So it will visualize the how many have errors, how many have warnings, and any other quality checks. It will visualize so that we will get a summary from this visualizations. And efficiency. It will improve accuracy of the deliverable and reduce the time we spent on ensuring a quality and a clinical data deliverable. So the Shiny will enhance the quality inspection of clinical programming deliverable by having all the integrated checks. They are automated, and you just with one click, the report would get generated on the deliverables. Whatever the checks we integrated, based on that, it will run. And it will have a dashboards along with the additional functionalities that will give flexibility to user, and as well as it will enhance the user experience. And these kind of apps will provide a customizable reports with the summary of visualization that user will be able to easily identify how many findings are there, then how many has to be resolved. So in our case, we have developed a Shiny app to address all these challenges. So we have used a that is created an R platform using Shiny. And some of the quality checks we perform internally had been integrated to that app. So they are not limited to the log or audit checks. So it can be many more. So we have integrated the sponsor level checks as well to the app, and we observed that improved the accuracy of the deliverable, and it would drastically reduce the time spent on ensuring deliverable quality. So now my colleague Sai Gayatri will take you through the app we created internally. And over to you, Gayatri.
Thank you, Vinod, for explaining the background behind our app. Hi, everyone. My name is Gayatri, and I'm also a clinical data scientist with Novo Nordisk. You can see on your screen a short visualization of the architecture of our app. It has been designed in such a way as to integrate with existing systems and to have a user interface that is intuitive and endlessly customizable. We start with the location of the input files, which is within the company's file system. The app takes in the input files depending on the particular quality checks that are to be performed, performs three sets of checks, which is to say quality checks, comparison of the outputs that can be included in the end of text, as well as comparison of two sets of data sets. These are displayed to the user in the user interface, and should the user choose to download them, it is possible to download an Excel file or an HTML file with hyperlinks in it back into the file system for maintaining of audit trails and for tracking of work. Vinod, could you please go to the next slide? I will begin with explaining very quickly the three different types of tabs that are available. One tab here is the quality report, which performs an exhaustive list of checks that we generally tend to perform manually in order to ensure quality within our trials. A few of these are visible on the screen from the results of the user interface. When the user selects a trial, the app checks for whether or not all the outputs that are supposed to exist in the trial actually exist. And it also goes through all the log files to check for any warnings or errors. There are a few other checks that are performed as well, which would previously be performed manually, and with this app can be reduced to a great extent. Could we see the next slide? The next is our output comparison, where when two sets of folders are selected containing two sets of outputs, it is possible to compare two different versions to see what has been changed. The example that you see on our screen summarizes the number of files that have differences between them. And on the lower tab, you can see the comparison of two different text outputs, which have the differences highlighted, which Vinod is also emphasizing with the mouse, as you can see here. Aside from comparing text outputs, it is also possible to compare PNG outputs, which we can see in our next slide. The red box that you see on the screen highlights the changes between the previous set of PNGs and the current set of PNGs, which emphasizes to the user that there has been some difference between the two sets of folders. Then our third set of checks compares data sets. There are three levels of checks that are performed to the data sets. The first being at the table level, which is for each table, it checks the number of observations between the two sets of data sets. For example, a use case might be having multiple runs of the programs creating the data sets, and you can compare what changes have been performed between them. So this the next is, of course, the table variable level, which would check whether or not the variables have been changed, whether there have been any changes to the labels or even the data types. The third set of checks checks the values within these variables, and all the differences are summarized in a tab in the user interface and can also be accessed through the HTML. So these three sets of changes are all things that would previously be performed manually or using various types of internal checks. But with this app, we've been able to combine them all into one singular space. Vinod, over to you for our conclusion. Thank you so much.
Yeah, thank you, Gayatri. So in general, when we use the Shiny apps, we can enhance the quality and efficiency of clinical programming deliverable. Rather, we perform the manual checks, or we use some piece of SAS codes or R codes, which is a time consuming, prone to errors. So we can create such kind of apps to improve the QA, quality assurance outcomes of our clinical programming deliverables. Yeah, that's it. Yeah, that's the conclusion. Thank you.
So someone asked, can you share the R packages you used? I guess which ones were the main winners for there?
So we have internally developed packages in the Novo Nordisk we have used for the PNG comparison. And for the text comparison, we have written a scratch code. We have not used any public packages here. And for the normal data manipulation and all, we use the deployer, that is Tidyverse umbrella packages we have used.